Good morning, students. Myself Sujay Kumar, mathematics teacher of Modern English School, New Area, Nevada. Dear student, today I discuss the new exercise 13b. This exercise is the elimination. It is the big brother of identities, and we use so many identities in this chapter. So you be careful and you see here how we can solve the problem of elimination of exercise 13b. Now in exercise 13b, question first, that is a cos theta plus b sin theta is equal to m, and a sin theta minus b cos theta is equal to m, and you have to prove that m square plus n square is equal to a square plus b square. First to write, m is given a cos theta plus b sin theta. Your question is m square, so first we are squaring both sides. Then it is m square and it is a cos theta plus b sin theta whole square. It is m square, it is a plus b whole square, so write a square b square 2 into a into b. It is equation first. Similarly, n is equal to a sin theta minus b cos theta. So n square is equal to a sin theta minus b cos theta whole square. Then n square is equal to a square a sin theta whole square plus b square b cos theta whole square minus 2a sin theta into b cos theta. Your question, m square plus n square. M square is there, n square is there. It is equation first and this is the equation second. So your questions adding to equation first and second, LHS side and RHS side. So m square plus n square. It is LHS, m square plus n square, and RHS is a square cos square theta, b square sin square theta, plus 2a cos theta b sin theta. Similarly here, a square sin square theta, b square cos square theta minus 2a sin theta b cos theta, because here is a minus b whole square. Then this 2a minus cos theta and here 2a cos theta sin theta cancel. So what you get now? You get here, that is, you write here m square plus n square is equal to a square cos square theta plus b square sin square theta plus a square sin square theta plus b square cos square theta. Now a square cos square theta and a square sin square theta at one place, and b square sin square theta and b square cos square theta in other place. Here is a square common, then it is cos square theta plus sin square theta. Here is b square common, so here is sin square theta plus cos square theta. Now it is identity first, it is also first, and value of this identity is 1. So write here a square into 1 plus b square into 1. Then you get a square plus b square, that is proved, and it is RHS. So now you see next question. Now see third question of exercise 13b. Question is that xy sin theta minus yy cos theta is equal to 1, and xy cos theta plus yy sin theta is equal to 1. And you have to prove that x square by a square plus y square by b square is equal to 2. So student, first equation is this, x by a sin theta minus y by b cos theta is equal to 1, and second equation is this, x by a cos theta plus y by b sin theta is equal to 1. First we are squaring both sides of the equation and adding first and second both in one equation. So squaring this equation, that is x by a sin theta minus y by b cos theta whole square is equal to 1 square, because RHS is 1, plus x by a cos theta plus y by b sin theta whole square is equal to also value is 1, so plus 1 square. What you get here? Here is a minus b whole square. At the place of a is x by a sin theta and place of b y by b cos theta. So use the algebraic formula, that is a square, that is x by a sin theta whole square, plus b square, that is y by b cos theta whole square, minus 2ab. So 2 into a into b, plus is this. So I write here plus. It is a plus b whole square. So I write here a square, that is x by a cos theta whole square, plus b square, that is y by b sin theta whole square, and here is plus. So we write here plus 2 into x by a cos theta into y by b sin theta. But this is 2ab and this is 2ab, both are same. Only literal form only retain either sides, but both are same. One is negative sign, another is positive sign. So you cancel it. It is minus 2ab, it is plus 2ab. So cancel it. Now you have only 4 terms. So write it. X by a sin theta, that is x square by a square sin square theta. Y by b cos theta whole square, that is y square by b square cos square theta. And plus here is x by a cos theta. So you write here x square by a square cos square theta plus y by b. So write y square b square sin square theta is equal to 2. So I write here 2 because 1 square is 1, 1 square is 1. So RHS 2, we write here RHS is 2. Now last step, that is here is x square a square sin square theta, and here is also x square by a square cos square theta, plus here is y square b square cos square theta, plus y square b square sin square theta is equal to 2. Because RHS is 2 given, so now take common between them. So here is only common x square by a square, bracket sin square theta plus cos square theta, plus here common y square by b square, here is cos square theta plus sin square theta is equal to 2. Then x square by a square into 1. It is the first identity, value of sin square by cos square is 1, and plus y square by b square, and value of this is also 1 is equal to 2. Then you get result, that is x square by a square plus y square by b square is equal to 2 proof. It is easy. Here. In question number 5 of exercise 13b, that is if x is equal to b sec q theta, comma y is equal to a tan q theta, then prove that x by b power 2 by 3 minus y by a power 2 by 3 is equal to 1. So first you write LHS, that is x by b whole 2 by 3 minus y by a whole 2 by 3. Only substitute the value of x. What is x? B sec q theta. So in these questions I put the value of x only. So b sec q theta by b minus value of y a tan q theta. So I write here a tan q theta by a. A cancel and here is b cancel. Here is sec q theta whole to the power 2 by 3. So I write sec q theta power 2 by 3. Here tan q theta power 2 by 3. 3 to the power 2 by 3. So multiply them. So I write here sec 3 into 2 by 3. Because here to the power 3 and whole 2 by 3. So 3 into 2 by 3. Similarly tan 3 into 2 by 3. 3 cancel. Here also 3 cancel. So get here sec square theta minus here tan square theta. It is second identity in your syllabus. Sec square minus tan square is equal to 1. So you write here sec square theta minus tan square theta is equal to 1. You substitute the value and get your results. That's okay. Yes, now you see last question of today of exercise 13b. Next question I solve the next day. Question number 7. That is, if cot theta plus tan theta is equal to m and sec theta minus cos theta is equal to n, then prove that m square n power 2 by 3 minus mn square power 2 by 3 is equal to 1. First your question m is given, but in the form of cot plus tan. First you change in simplest form, that is sin and cos. So cot theta you write cos by sin plus tan theta sin by cos. LCM sin into cos. Here sin divide, then you get cos. Cos multiply by cos, you get cos square plus cos divided, then you get sin, and sin multiply, then sin square, then cos square plus sin square is equal to 1. So m is equal to 1 by sin theta into cos theta. Similarly, here is n and it is equal to sec theta minus cos theta. This sec theta is equal to 1 by cos theta and minus cos theta. Take LCM, it is cos. Cos divided cos, you get 1 into 1 1. Cos divided by 1, then you get cos and multiply cos, that is cos square theta. But 1 minus cos square theta is sin square theta and by cos theta. Now substitute the value in the equation only, so you get your solution. That is m square n power 2 by 3 minus n square power 2 by 3. What you get? M square n 2 by 3, mn square whole 2 by 3. Value of m is 1 by sin into cos. Then square it. So you write 1 by sin square into cos square into n, and n is sin square theta by cos theta. So write here sin square theta by cos theta whole square power 2 by 3. And here is minus. So I write here minus m. Value of m is 1 by sin theta into cos theta into n square. So square this, you get sin 4, and here is cos square. First you cancel it. It is sin square, then cancel this sin square. Here is sin 4, here is sin theta. So it is cancelled by 3 times, that is sin cube theta. And then you write here is 1 by cos square and here is 1 by cos. So it is 1 by cos cube theta and power 2 by 3 minus sin 4, but here you cancel it is 3. So sin 3 by cos 3. So write here sin 3 theta by cos 3 theta power 2 by 3. Next it is sec cube theta power 2 by 3. Here is tan cube theta power 2 by 3. Power multiply, then you get here sec square theta because 3 cancel, and here is tan square theta and it is equal to 1, that is RHS, and it is proved. And next proof I solve it next day. Thank you very much.